The metalloids reside between the metals and nonmetals on the periodic table. They exhibit some qualities of metals and nonmetals. Many metalloids act as semiconductors by behaving as electrical insulators at room temperature, but electrical conductors when heated. This property is vital to the computer industry. Boron is a yellow-brown crystal. This non-metallic element is used to make high-strength and lightweight aerospace equipment. When it burns, boron gives off a distinctive green glow, so it is a main element in green fireworks and flares. Silicon is a hard, dark non-metal. It is the second most abundant element and makes up 25% of the Earth's crust. A large part of sand, clay, granite, and quartz is silicon. This useful element goes into solar cells, tools, cement, grease, and perhaps most importantly, semiconductors and computer microchips. Germanium also goes into computers and electronics. This hard, brittle, gray-white metal is used to make transistors, semiconductors, infrared optical instruments, and wide-angle camera lenses. Arsenic is a gray, brittle non-metal. It is a deadly substance that has been used to make rat poisons and insecticides. It is also used in the manufacture of metal alloys, mirrors, glass, lasers, and semiconductors. Arsenic is a byproduct of copper forging, and it could provide evidence about when our ancestors began to make copper tools. Antimony is a hard and brittle blue-white metal that is a poor conductor of heat and electricity. It helps make lead alloys more durable, and it goes into flame-proofing materials, lead batteries, mascara, paints, glass, pottery, and plastics. Tellurium is a silver-white metal-like non-metal. Small amounts of this element are added to copper and stainless steel alloys to make them easier to work with. It also colors glass and ceramics. The rare radioactive metal polonium is used to make nuclear batteries. It is currently under consideration as a possible heat source on spacecraft. Small amounts of polonium are used in shielded brushes that remove dust from photographic film. The metalloids are a diverse collection of elements. Most are brittle, somewhat shiny solids that exhibit properties of metals and nonmetals. Some of them, such as antimony, have the appearance and luster of metals. But others, such as arsenic, clearly appear to be nonmetals. Their chemical properties range between those of metals and nonmetals. One of the most unique properties is semiconductivity. Acting like nonmetals, semiconductors block electric currents at room temperature. But when they are heated, they act like metals, allowing electricity to flow through them. This unique property makes the metalloids, particularly silicon and germanium, valuable to the computer and electronics industries, where semiconductors are used in everything from calculators to computer chips. The metalloids form the line that runs between the metals and nonmetals on the periodic table. They span groups 13 through 16 and have anywhere between 3 and 6 valence electrons. The atomic structures of the metalloids lie squarely between those of the metals and nonmetals. For example, boron has 3 valence electrons and usually acts as a metal by shedding its valence electrons during chemical reactions. Arsenic, antimony, tellurium, and polonium have more than 4 valence electrons, and they typically act as nonmetals by gaining electrons from other elements. Meanwhile, silicon and germanium, with exactly 4 valence electrons each, sometimes act as metals and other times as nonmetals. The metalloids and their great variety of properties are valuable for many industrial materials, from transistors and semiconductors to ceramics, solar batteries, and certain polymers. The metalloids may be the strangest and most useful of all the element groups on the periodic table.